Auzubillahiminash-shaytanir-rajim. Bismillahir-rahmanir-rahim. Assalamu alaikum, dear students. As you know that we discussed about the Doppler effect, and Doppler effect is the apparent change of the frequency of the sound generated by a sounding source when there is relative motion between sounding source and listener. First, we discussed about the case in which we consider the listener in state of rest and we move the sounding source towards and away from stationary listener, and we find out the expression for the frequency as well as expression for the wavelength. Now, second case, we consider the listener in motion and we consider the source in state of rest, and we find expression or change of frequency when listener move towards the sounding source which is in state of rest or away from the sounding source which is in state of rest, and we also find the expression for the frequency in this case. Now, we also know that there is change of frequency when both sounding source and listener moves towards each other or away from each other. In third case, we just take the both source and listener in state of motion, and in the first part of your third case is source and listener both moves towards each other. We consider a sounding source and a listener L, and in first case both the source and listener move towards each other, means sounding source and listener approaches each other. Here we have a sounding source and a listener L. When both are in state of rest, then the wavelength generated by this sounding source is lambda is equal to V by F. F is the frequency of the sound and V is the distance between the sounding source and listener when both are in state of rest. Now, when sounding source move towards the listener, due to the motion of sounding source towards listener, there is change of the wavelength, because here wavelength is distance between the sounding source and listener and frequency. So when sounding source move towards listener, the distance between the sounding source and listener changes. Here let's its sounding source S move towards listener L with certain speed A, then it's cover certain distance A, then the distance between sounding source and listener is V minus A. V is the distance when both are in state of rest. Now if listener move, let's reach at that point and the distance from this point to this one is A. Now the total distance, which is originally V, now this distance become V minus A. Now distance is up that point to that point. This distance is V minus A. So due to change of the distance between sounding source and listener L, the wavelength changes. The new wavelength due to motion of the sounding source, we have V minus A by F. V minus A is the distance between sounding source and listener. So there is change of wavelength, which is V minus A by F. This expression showed that this wavelength decreases from original wavelength. So the wavelength decreases when sounding source move toward the listener. Now if we consider the motion of the listener, here in this case listener also move towards the sounding source. So when listener move towards the sounding source, the speed of the sound changes. Here originally sound move with speed V when both listener and source are in state of rest. Now listener move towards the sounding source, there is change of speed. Wavelength due to motion of the listener remains same, but speed changes. So the change of speed, originally the speed is V. Now listener move with speed B towards the source. Now the new speed is V prime, which is equal to V plus B. Originally we have speed V when both are in state of rest. Now this listener move towards the sounding source due to its motion towards sounding source with speed V. New speed of sound become V prime, that's equal to V plus B. V is the speed of sound and B is the speed of the listener. Now we know that frequency is equal to V by lambda. V is speed and lambda is the wavelength. So the new frequency we have V prime by lambda prime. V prime is the new speed which changes due to the motion of the listener towards the sounding source, and this lambda prime is the change of wavelength, and wavelength changes due to the motion of the sounding source towards the listener. So in this case the frequency changes due to change in speed as well as change in the wavelength. So we have new expression of frequency. The apparent change of frequency represented by f prime is equal to v plus b, that is the value of v prime, and v minus a by f, which is the value of lambda prime. So the new frequency f prime is equal to v plus b divided by v minus a into f. What we conclude from this frequency expression, that frequency directly related with speed. When speed of the sound increases, then frequency increases, and it's inversely related with the wavelength. When wavelength decreases, then frequency of the sound decreases. When sounding source and listener both move towards each other due to motion of the sounding source, the wavelength decreases. Here frequency inversely related with wavelength, so frequency increases, and frequency directly related with the speed. So due to motion of the listener towards the sounding source, then speed increases, new speed become v plus b. So due to increase of speed, again frequency increases. In this case wavelength decreases, due to decrease of wavelength frequency increases, and in this case speed increases, due to increase of speed frequency again increases. So we concluded that when sounding source and listener both move towards each other, then resultant frequency of the sound increases, and due to increase of frequency the pitch of the sound also increases. This is the third case in which sounding source and listener both move towards each other, both approaches to each other, then there is frequency of the sound increases, frequency received by the listener increases due to increase of the speed of the sound due to towards motion of the listener, and due to decrease of the wavelength towards motion of the source. So as a result frequency increases and pitch also increases. Now we discuss the case when source and listener move away from one another.